Alright, so look at the syntax. If you can read the syntax and make sense out of it without any problems, you don't really have to watch this video. But if not, I guarantee you by the end of this video, you will be able to read it seamlessly. So if that is the case, stick around and watch till the end. Now, before even getting into what a generic is, why do we even need it? By definition, a generic is something that's not specific, but TypeScript is all about being as specific as possible. Any data that you use in your TypeScript application, the compiler would want you to define its type. That's the whole point of having strict type checking. But there are scenarios, actually many scenarios, where you would not necessarily know what the type is when you are in the defining phase. This is the key term here, the defining phase. What do I mean by it? Let's look at an example. Imagine you have an admin dashboard for an e-commerce website. Every e-commerce app should ideally have users and a product. So somewhere on this admin dashboard, you'll see the list of all the users and a list of all the products. Let's first create interfaces for these two entities, the user and the product. So I have a React application here. You don't really have to do anything with React for this. All you need is TypeScript, but since I already had it scaffolded, I'll use this application for this example. So we need to create interfaces for the user and the product. This is what they would ideally look like. Obviously, it's very simplified and dumbed down, but you would have something similar in your application as well. So I hope you get the idea. Now to fetch the list of users and products inside this dashboard, you'd normally write functions like these. You have this fetch users function that makes an API call to this endpoint. You get the response back and you just return response.json. Similarly for products, it's more or less the same, but the only difference that you would see is the API endpoint. So if the internal logic is pretty much the same and the difference is just the URL, you don't really need two separate functions for it. We can create a common function. So let's refactor this example a little bit. I now have a common function that takes in a URL and returns a promise. And whatever URL I pass to it, based on that, it's going to fetch that specific resource. So if it's fetch users, then it's going to fetch the list of users and it will be products in case of fetch products. So we did solve the problem of repetition, but now we have a new problem. We won't really know what type of data we'll get back from the API. Since it's a common function and it will be used for all fetch requests, we can't possibly predict what data we'll get, which also means we can't predict its type. If I go back to the previous example, we knew that this fetch users function is going to return a promise of an array of users, and similarly fetch products would give us a promise of an array of products. But now this current example, we're not really sure because it's a common function, and only when we invoke this function will we come to know what type of resource are we getting back. During the definition phase, we won't really know what exactly the data would be because this URL also is dynamic. We won't really know which URL we are trying to make a request to. And if you have worked with TypeScript for even a small period of time, you'd know that using any is as good as using JavaScript. Ideally, there should never be an any keyword in your TypeScript codebase because it provides zero type safety. So how do we solve this problem? How do we make this function type safe, but at the same time keep it generic? The answer is in the question itself. We will be using generics. On paper, the idea is pretty straightforward. Give this function a type placeholder. So let me explain what that means. We won't know what the type of the response would be when we are creating this function because it's common for all fetch API calls. But we would know the type when we are invoking this function. So in here, we actually know that this is going to give us a list of users. Let me change this to users. We know for a fact that this will give us a list of users and this will give us a list of products. So in the dashboard, when you open up a page that renders the list of users, you know the API call that needs to happen, which also means you'd know the response type. So that's the key point. While defining something, you're making it generic, but when you're using it, you can drill down and provide more type safety. So let's tweak our example. Now, understanding generics is not a challenge. It's a simple concept, but the syntax absolutely sucks. There's no way around it. And for now, you'll have to brute force through it. practice as much as possible, and eventually this ugly mess that I'm about to show you would start to make sense. So to make this function type safe with generics, you use angular brackets and provide the type placeholder. So here in this common function, I pass in this type placeholder inside this angular bracket syntax. Normally you would see people using this syntax everywhere, but you don't really have any restrictions. You can name it pretty much anything and it would still work. I would actually recommend you when starting off to give it more meaningful names instead of just letters. So let's actually change this to response type. Now here it will treat it as a tag since it's a JSX file and the compiler would assume it to be a React component. So there's again an ugly workaround for this. You can add a comma after this type placeholder and that should solve the problem. I know it's just bad design, but you'll get used to it. And we have defined this placeholder type so we can use it anywhere in this function. In this case, it's going to be the return value of this function. So inside the promise, I'll pass in this generic response type. And that's it. Your function is now type safe with the help of generics. Now, when I'm invoking this function, I need to place the actual type for the placeholder. So in case of fetch users, it will be an array of users, and in case of fetch products, it will be an array of products. If I actually remove this for now and I hover over this fetch users function, you see that the return type is a promise of unknown data type. But if I revert and bring back this generic, you'll now see that the type is a promise which resolves to an array of users. Now I have a confession though. In this example, you don't really need generics. You can very well remove the generic type altogether from here. I can again bring it back to any, and I can set the return type for this function to be a promise of a list of users, and similarly here it would be a list of products. This again would work the same way, and you'll still get somewhat similar type safety with this structure. So for this specific example, you can get away with not using generics and still have somewhat similar type safety. But this next example is where things start to get interesting. Imagine you have an array of products of different categories. You'd want to create a type safe filter function that takes 3 arguments. The first one is the array itself. The second argument would be the key, and the third would be the value. So for example, if I want to filter just the electronic items, I'll invoke this function with key as category and value as electronics. That would give me all the electronic items. I can also filter based on the name and the ID. Obviously, in this case, since both are unique, you'll see that all the ID values and the name values are unique. It's less filtering and more finding. So I won't really get a bunch of values when I try to filter this list using ID or name. I'll just get like individual values. But yeah, you can still do it based on any key that you would find inside this object. The filter function is pretty straightforward. I don't really have to explain what this does. But let's try to make this type safe. For now, you can see that we have used the any keywords all across this function. Let's not do that. Let's make this type safe. Now, at the end of the day, this is a generic function. I can use this filter function for pretty much any array of objects. So if I have an array of users like so, I can still use this filter items function on this users array, and I'll be able to filter it without any problems. So that's the power of generics. You don't really have to write repetitive code for different kinds of data types. You can use this function for a lot of similar data types if it's built in a generic way. So yeah, let's remove this for now, and let's add a type placeholder to this function. I'll call it item type, and I'll have to pass the comma again. The array filter returns an array of the same type, so that's why I'm using the same generic as the return type for this function. So if you take this array as an example, I'm passing this array inside items, and at the end of this filter operation, I'm getting the same array type. So that's why I have both the types set to this type placeholder. Let me also invoke this function here at the bottom. Now if I hover over filtered products, you'll see that TypeScript has already started to infer its type. The type comes from what we pass as the first argument, which in this case is this products array. The TypeScript has already started to figure out the type of this filtered products array. The second parameter is kind of generic though. I pass it as a string, sure, but it can only be ID, name or category in this example, right? I don't want the person who's using this function to pass in anything other than the keys in these objects. Let's add some constraints. It's pretty straightforward actually. All you have to do is change this string to key of item type. This means whatever array of objects you pass into this function, you'll only use keys present on those objects. So if I revert back to string, I'm allowed to pass in anything as the second parameter. So if I change this to QQQ, this won't give me an error. But if I change this back to key of item type, now if I try to pass in anything other than category, ID or name, I should get an error from TypeScript. You'll see that it expects the second parameter to be of type ID, name and category. It's only going to take in these values and not anything else. There's one more layer of type safety that we have added to this function. We can only pass in the keys that are present on each object. So I'll bring this back to category. Okay, so we have constrained the types of the first parameter and the second parameter. Now you'd think I'll do the same for the third parameter as well. But this is where you should consider a few things other than type safety. So if I try to bring in type safety for this third parameter as well, is it going to be developer friendly? Can I have a more type safe type other than any, which means a string or a number that's not extremely type safe, but it still gives you one layer of protection? Can I do that? Is there even a requirement to have an extreme level of type safety here for this third parameter? You should ask all these questions before using generics because there can be alternatives to it that are more easy to read and give you more or less the same set of features. But I'll do it anyway. The first step would be to not have any as its type. So let's get rid of this. So if I know beforehand what type of values can be present for each key in this object, then I can set the type to a union. So for instance, in this example, it will either be a string or a number. So if I have passed in key as ID, then the value can only be a number. If I pass in the key as name or category, it can only be a string. So I know that for this particular example, which means I can set this to either a string or a number. It's a union type. But obviously this is not the right way because an object can have a lot of keys and each key could be of different types. You can also have complicated nested objects. So you'll have to manually look for all the types and set the value that way. So this is clearly not it. What we can do is introduce another placeholder type for value. So we already have a placeholder type here. We can introduce another one just like we do with function arguments. We can do something similar here. I'll introduce a new type here and I'll call it key type. And the values type now becomes item type and key type inside square brackets. So just like square bracket notation for objects, we can use something similar here. Item type is the object itself. So you can think of item type as this, and key type would be any of the keys. So key could be name, ID or category. So item type and the key type. And since we are using key type in here as part of value, we can do the same over here as well. But we need to move this constraint over here. So this might actually be a little confusing, but let me actually replace this and show you what I mean. So I simply moved key of item type inside this generic itself, and I replaced the type for key with key type. Now items is going to be an array of this type. So you can think of item type as the type for any one of these objects, and items is an array of those objects. Key is any one of the keys inside each object. So ID, name or category is what I can pass in inside key. Now here we actually need to add the extends keyword as well, because in case of generics, that is how you provide a constraint. key of item type would have worked when you just pass it as a type, but when you're using it as a type placeholder, you have to use the extends keyword to add that constraint. So now key is of type key type, which can only be ID, name and category, and value is going to be any one of these values. So item type is this one object and key type is any one of the keys. So ID, name or category. So again, one more time, we have the item type, which is going to be the type of object inside the array. Key is of type key type. This key type has a constraint that it can only be a key of the item type. It can only be ID, name or category. The third parameter is set to item type and key type inside square brackets, which means whatever key I have passed inside this second parameter, so category for instance, Typescript will look at the object and the category key and see what all value types are supported there. So for us, the supported values should ideally be electronics, furniture and clothing. But if I try to type in something in here, I don't get any suggestions from the IntelliSense. You can clearly see that I've passed a random string and Typescript gives me no errors. Why is that? We were expecting it to be either electronics, furniture or clothing, but I can still pass in this random string. So let me do one thing. I'll replace this string with a number and let's see if we get any errors then. So now I have 2 here and you'll see that we do get an error and it tells me that you cannot assign a number to a parameter of type string, which means it's still expecting category to be of type string and not specific literal values like electronics, furniture or clothing. If I hover over filter items, you'll see that the third parameter category is still of type string. But we know for sure that the category will only have a set of literal values. So I can do one thing here. Now, mind you, this is not the ideal way to handle this problem and I will give you an alternate solution. But for now, bear with me. I can tell Typescript somehow this category has a set of literal values and it's not of type string. To do that, I can set it as a constant. So after each category value, I can set it as a constant. Let me do that for all the objects. And now if I try to replace this with some random string, you'll see that we get an error and we've already seen that we get suggestions from the IntelliSense as well. So I can only pass in these 3 values, which means Typescript is considering category to be of a literal type and not a generic string. Again, this is an ugly hack, but it does get the job done. Now I get the error with the types expected for the third parameter based on the key that was selected as the second parameter. But Typescript has inferred generic types for name and ID. So if I set the second parameter to name and the value to something other than these values, you can already see that we are not getting an error. And electronics is not part of the list of names that we have in this array. So we are not really getting an error, which means name is still of type string. So the way we converted the category values to literals, we can do the same thing for the entire object. So what I will do is move this outside the object and I'll save this. Now you can clearly see that we are getting an error and it's expecting values from the list of names that we have for the name key. So it will only accept laptop or any of these values. But in reality, this would never be the case. If you have a list of million items, it's expensive for Typescript to compute a million literal values for names. Anytime you do this anywhere in your application, Typescript has to go through a lot of rows to check whether this literal type is present on that name key. That is a very expensive operation. But category on the other hand would have a limited set of values which you would know beforehand. So instead of converting each object into a literal, what I can do is create a type where I know beforehand that category will have a list of literal values. I can create a union type for it. And ID and name for the most part will be generic numbers or strings. So this makes things easier for us and it's more practical. Typescript will also not go through the entire list of IDs and names just to keep this function completely type safe, even though we don't really need it. So that's how you'd use generics to create common functions that can be used on different data types without losing type safety. What you'd normally see is a bunch of T's in place of these types. So what I can do is replace item type with T and replace K type with K. We are back to the example that we saw at the beginning of this video, but you don't really need to do it this way. You can give it whatever names you want so that it's more readable and developer friendly. Also, I completely forgot to mention this, but I'm sure you already have worked with generics. You may not have written one yourself, but take this filter function for example. If I go to its Typescript definition, you'll see the same T here. And this T comes from somewhere over here. Yeah, you can see here that it's coming from this interface. This also means that you can pass generics to an interface as well. I'll come to that part in a second, but let's see how this works. So you pass a generic to this interface, and this I believe is the type of the element inside an array. So the filter function basically takes in a function as its parameter, like we saw here, and each item inside this array is of this generic type. This could be anything, a string, a number, anything. And the return type is also an array of the same placeholder type. So that's what I'm saying. The filter function behind the scenes does use generics. And since we are in a React app, let me give you one more example. Let's add a simple use state over here. If I go to this use states definition, you again see this S over here, which is the placeholder type. This is also a generic, since use state will never know what values you pass to it. We can pass in anything we want. So yeah, use state also uses generics behind the scenes. This S equal to undefined basically sets the default value for use state. So if you don't pass in anything to use state, it is going to be undefined by default. So what I mean to say is, generics are everywhere and it's almost impossible that you've not worked with them. Any common function that's being used for different data types, it's basically a generic. Alright, one final thing that I wanted to cover is that generics can be used with pretty much anything. We already looked at functions and briefly went through interfaces when looking at the filter function's Typescript definition. You can also use it to create types dynamically. We have an employee type here that has some metadata properties. These properties will be common for each type of employee, but then there's department-specific properties that may not be the same. You can use a generic there to create a generic type and use this to create other types dynamically with properties unique to that type. You can also use generics with React components. Take a look at this example. We have a generic list component that renders a list of items. Now the type of the items could be anything. You could have a list of strings here and a list of products, and both use the same generic list component internally. We pass the generic to the component. I hope by now you are slightly more familiar with this T syntax. You pass this to the component, and from the props, you use this generic as a replacement for the type of the item. The second prop is the render item function that dynamically renders content based on the type of the item. This again is a very common React pattern called render prop pattern. I have a separate video on it which I have linked in the description, but to give you a brief, what this pattern does is render content for a component dynamically based on some condition. For example here, since we know the string list will just have a bunch of strings, I can render it this way, and in the case of product list, I need to render the name of the product, so it will slightly be different. We are passing the rendering logic as a prop to the component, which is why it's called the render prop pattern. This way you can create a generic React component and use it for different data types by also keeping it type safe. The best part here is that you don't even have to manually pass the type here when using the list component. Typescript will infer the type from the props itself, which makes it even more easier to use. So yeah, you can use generics pretty much anywhere in your Typescript codebase. I agree that the syntax is ugly, and I also do agree that you have workarounds for it. But if you understand this thoroughly, you can reduce a lot of repetitive code with more generic yet type safe options. Do give the docs a read and try creating a few generic functions, types, components, and interfaces of your own. Once you have a grip on it, I guarantee you won't stop using it. I'd also recommend you to read more about the extends keyword used in generics I did go over it briefly on how it constrains a type to a more specific type, but yeah, take it up as an assignment and read up on it. Other than that, if you have any other doubts or suggestions, do let me know in the comments and I'll see you in the next one.